All right, get started. Okay, well, welcome. It's day three, so we'll try and make it useful. And essentially, the rationale behind looking at cost is multifold, so I'll touch upon some of those. But when it relates to Yahoo in particular, we have two sides of things. One that develops a lot of software in open source, Apache Software Foundation, and the other side of things that actually then takes all of that, deploys it on a massive infrastructure, and offers it as a service for the entire company. So it's a very interesting dynamic, and when you think about costing, or you have a common scalable platform, costing actually becomes quite important. So if some of you are on the business side of things, or are thinking about becoming a Hadoop-driven business, you will see this question come up often. And our hope is that we will share our approach as to how you go about answering a lot of those questions. So that's the essence of this talk. And before we begin, let us introduce ourselves. So my name is Sumit Singh, and I'm Senior Director of Products at Yahoo. I manage the Hadoop products at Yahoo. Amrit Lal is also a product manager, looks a lot after HBase, Storm, and Hive. So we're trying to cover Hadoop, HBase, and Storm, all of that in terms of how you go about costing them over those operations if you have an infrastructure that is about to scale up or eventually scales up in the future. Okay, so the agenda, one of the first things you might want to think about is the total cost of ownership, because cost, oftentimes when people get asked the question, they will just think of number of servers and how much those servers cost, and that's a really bad way to look at it. Whether you have a public cloud infrastructure or you want to deploy your own infrastructure in a private cloud. We'll also touch upon, we'll spend majority of our time thinking about understanding resources when it comes to Hadoop, HBase, and Storm, because that's what's crucial. That's what you're going to bill people for or charge people for, or that's how you're going to cost yourself. Then we'll get into how all of those concepts can be extended into running, let's say, your group or organization as a business. We'll also touch upon then how you can enable metering or billing provisions. In our case, at the cost basis, so we'll stay at the cost basis. We'll not get into pricing aspects of things. And then we'll share an approach to how you think about cost competitiveness. So how would you go about benchmarking yourselves against others? And then finally, some thoughts around improving utilization, which is crucial to optimize the investments, and then returns on investment. Right? So that's the overall agenda. And then, as I said, costing is, you have to answer the questions around cost for a number of reasons. And the first reason is profitability. So if you have a project that utilizes these infrastructure, so you run your project on a Hadoop infrastructure, or you use HBase or Storm, you have to answer the question if your project is generating revenue for the company because you incurred, let's say $10 million on that infrastructure. How do you go about doing that if you don't know what that infrastructure costed you? So it's really important just for basic project management. Return on investment or investment decisions can be made when you understand the true cost. Operational efficiencies are also, I would say, an area which you can look into if you understand your true costs. So there are a lot of things you can do to operate efficiently. And essentially the idea is that you're trying to maximize for what you have invested. And then planning for planning purposes. So capital planning, particularly when your infrastructure runs into millions of dollars, that's something you will have to do, an exercise you will have to go through every year. Right? So something like this is very useful for that as well. And then finally, you want to be transparent in your operations, right? You want to understand where are the costs in your operations. So a lot of those elements come in, okay? And as I said, it's relevant. It doesn't matter what type of infrastructure operations you go after, be it your own or private cloud, or you utilize public cloud infrastructures. You have to think about cost holistically. It's not just the bill that you receive from the public cloud provider. It's a lot more than that. So you have to think about the headcount in both cases. You have to think about I would say the dynamic that are involved in both situations. So there are a lot of elements for consideration here. We're not going to get into the considerations and whether this is better or that is better. We just want to highlight the fact that whichever way you go, costing is important. Okay. And then it gets to become really relevant as your operations scale up. So in our case, we've been doing this 10 years, and it starts to get asked more often than not. When we started, it wasn't as important, but now it's becoming important because of the scale of operations we have, right? So that's the Hadoop scale. And this is where it gets even more relevant because now you have a common platform where you're onboarding projects onto them. The projects want to know what it's going to cost them. So that they can get approvals, they can get necessary, I would say, capital procured and things like that. So it gets to become really important with scale. HBase has the exact same story, and so has Storm. So as you start investing in these infrastructures, you'll start to realize that cost becomes a really important element in the overall discussion. So where does those dollars go? I just want to highlight that. So this is a conceptual view of our operations, entire operations. And you can see majority of those dollars go in the data nodes for Hadoop, the region servers for HBase, and then the supervisors for Storm, right? They are all sharing a common network backplane. So network is another big infrastructure that you have to spend on as you scale up. All the other things in the ecosystem are not that big, right? Hive or Hive Server 2, a lot of those are client-side concepts. Even if it's, let's say, on the server side, the installs for those are minimal, even in our cases. A few servers to a few tens of servers or hundreds of servers, but not thousands, right? So majority of the dollars are going into those. I've highlighted that as the red box. That's where the dollars are going, project by project, as you scale your infrastructure. Okay, so what are we going to talk about here? This is the stack we have assembled, what we have as of today. And we're not going to cover everything, it's impossible. So we'll actually touch upon MapReduce and HDFS, which is Hadoop. We'll touch upon HBase, and we'll touch upon Storm. Okay? So from a customer standpoint or consumer standpoint, who's consuming these services, resources are of what's important to them. And when you think about resources in a Hadoop infrastructure or any big data infrastructure, there are really just four that they care about, the customers care about. The bandwidth is one, right? So the transfers in and out of clusters. The second is storage, the data that they bring in, the data they store, the retention, and all of those aspects around storage. And then memory, which is essentially the compute units in Hadoop. And so different people have different memory requirements to run their tasks. And then finally, CPU, which is also aiding the processing of tasks. Right, so those are the only four things essentially customers care about from a resource standpoint. What do platform guys care about? What do we care about? We care about the total cost of ownership, right? So let's look at how you're going to go about calculating the total cost of ownership. It doesn't change what type of infrastructure you have, whether it's HBase or Storm or Hadoop. Right, so the first and the single most important, I would say, at least in a scalable infrastructure, is the hardware itself. And there are all kinds of hardware, not just data nodes. There is name node, there is job tracker, there are gateways, there are proxies. So you have to account for all of that hardware cost, okay, and depreciate that appropriately. We do it for 3 years. You can choose something different if you want to. Then you have to account for the platform headcount. Or R&D headcount. As I said, we have two houses, right? One, the development house, and then the operations house. You have to account for both headcounts. So we do that. You have to account for the operations cost. So this is primarily the data center cost, and energy is the single most important component here. You have to account for network hardware because that can be substantial. You have to account for one-time acquisition and install costs. That can be substantial. You have to also account for, as I said, the headcount on the operations side, because as your infrastructure scales up, you need a lot of people to manage the operations. In our case, it's actually pretty good. It's not a lot. And then finally, network bandwidth is also an expensive commodity. It could be an expensive commodity if your operations span multiple data centers. Right, so if you take all those cost components, put all that together, you will get to your TCO. And hypothetically, let's say in our case, it's $2 or $2.1 million per month. Completely fictitious, but let's say That's how you're going to arrive to your total cost of ownership. Right? So now I understand my monthly total cost of ownership for the Hadoop infrastructure. Say, for example, for HBase, you're going to repeat the same process. For Storm, you're going to repeat the same process. Okay? Then the next thing you want to do from a customer standpoint is the customers care about, as I said, resources. So what are the Hadoop resources they consume today, right? It's very simple. On the data side, it's extremely simple. It's just the data that you store in HDFS. And that's on the left-hand side. So not complicated at all. On the right-hand side, the tasks also are, as at the moment, pretty simple. It's just chunks of memory where containers run. Either it's a map container or a reduced container, but essentially, at the end of the day, it's chunks of memory that you occupy for as long as your tasks ran. Right? That's pretty much it. So in Yarn, what you do is you carve out your node, the memory of the node, in fixed container intervals, which is called the min container allocation. And then you take multiples of that min container for your tasks based on how much memory the task needs. Right? So those are your container sizes. And then in terms of getting to a unit cost that you will then apply to the resources that people consume, it's actually, again, pretty straightforward. So the units for memory are $ per GB hour. So GB is the memory for map or reduced tasks, and the unit is $, per GB hour. Okay? And we've left the notion of slots with Hadoop 1. We're like 3 years past that notion. Okay? So, and then the way to calculate the unit cost for memory is that you take all available memory in your infrastructure and the cost of that compute infrastructure and just divide them, you get to a unit cost. I'll show you an example. On the storage side, you do the same thing. You take your total storage that is available in your infrastructure, the TCO monthly for that storage, part of the infrastructure, divide that, you get to the unit cost of storage. Okay? Bandwidth is somewhat different. So since we've accounted for the network hardware, we don't count for bandwidth within the data center, but as you go out, you're putting your traffic on the interregional links, and they can be very expensive. So all the traffic that are being generated from Hadoop clusters cross-colo or across data centers, you have to account for that bandwidth. So we do account for that. And that's, again, $ per GB of what you're transferring in and out. Okay? So let's take an example. The other commodity I want to highlight here is name node. There's something called as namespace. So name node has 3 things that it tracks: files, directories, and blocks. Right? And as the number of files, the number of directories, and number of blocks increase, the name node can only take so much. So let's say in our operation, single name node can go up to 400 million, let's say, namespace elements. So we actually track the quota very carefully. We don't charge for it, but that's something we track very carefully because you don't want to blow the name node, right? Because of too many small files and other things. So you just keep a check on it. So from a cost perspective, it's not applicable. Okay? So let's take an example. My TCO in that hypothetical example was $2 million, 2.1. So let's say $100,000 was for bandwidth. For the purposes of resources, compute, and storage, I ignore the bandwidth part. So I have $2 million in monthly TCO. In our case, the demand for compute and storage keep hand in hand. So it's very agreeable to actually split the TCO 50-50 for compute and storage. Right? So we buy servers with JBODs. It's totally acceptable to split that 50-50. You can apply a different approach if a different approach is applicable to you. So let's say $1 million goes to compute, $1 million of monthly TCO goes to storage. Right? And say in this hypothetical example, my total memory footprint of the Hadoop infrastructure is 315 terabytes of RAM. Right? So I take that 315 terabytes of RAM and give it a notion of time. So if I were to look at an entire month, how much of memory is available? So I multiply it by 24 hours for the day, 30 days for the month. I get to something called as 227 GB hours. So that's the unit. Because you have to have the notion of how long was that occupied for by somebody. Okay? And then you take that $1 million divided by that 227, you get to your unit compute cost. So let's say it's 0.4 cents per GB hour. That's what I'm going to charge people for, okay, for using my infrastructure. On the storage side, again, you can either work with raw HDFS or you can work with usable HDFS, right? So there's some overhead, and there's a replication factor that Hadoop uses for fault tolerance. So you have to account for those and take those out. So let's say in this example, my infrastructure had 200 petabytes of HDFS. The data I can store on this is about 53.3 petabytes. Okay. So you take $1 million of TCO, that was for the storage, divided by that petabyte, you get to a dollar per GB notion for storage. And let's say in this example, it's 1.9 cents per GB hour. Okay? And bandwidth, again, as I said, it's in and out. So we basically left the 0.1 million in this hypothetical example for bandwidth, and we measured the total transfers in and out of clusters, which was 5 petabyte. So I just divided that, and I got to my bandwidth cost. And for the rest of the presentation, the bandwidth calculation stays about the same. And then you get to measure the resource consumption. So I already touched upon this. It's the individual map tasks and the time those map tasks ran for, the individual reduce tasks, the time those tasks ran for. You sum all that up for a job, right? You get to the, and then you apply that sum with the unit cost you just computed. You get to the cost for that job. And once you get to the cost for a job, you can take all the jobs for a particular user for the month, for a business unit, for a project. You can roll all that up and present it as a cost to either that BU, that project, or that user. Right? So pretty straightforward. On the storage side, it's somewhat complicated but in our case, but may not be in your case. So we actually divide our storage in multiple hierarchies of projects, data. Data is like a shared data space. So we charge as a weighted average of who uses that across projects. And for project, it's pretty straightforward. It is for a project, so you can just go charge that project for the space, the amount of space that you're allocating to them. Okay, and then there's a user directory. You can charge that to a user who belongs to a project, who then belongs to a business unit. So again, pretty straightforward. You can roll all that up. And bandwidth is measured at the cluster level, so it gets shared across projects, and it's not substantial. Then the idea is actually, how do you measure that? How do you measure how long these things ran for? So Hadoop has a lot of counters, and there are a lot of parameters that you can look at in terms of measuring it. This is just an example of a resource manager where you have various queues. So we use capacity scheduler where the jobs are going. And then there are various configurations or capacities that we've allocated to them. And the idea here is that the SLA is a very simple notion of the capacity that you're allocating to that person in terms of how many concurrent mappers and reducers he runs. So pretty straightforward. And we have an automated system through which we measure. So we pull all those logs together in one place, and we analyze the counters and the job logs to put together the total cost for that job, right? So. And then you can put all that together in the form of a bill for the project, for the BU, whichever the case may be. It's pretty straightforward because now you know the unit costs, you know the resources they consumed. It's not any difficult, right? So with that, I'm going to invite Amrit to talk about HBase and Store.
Sure. So now that you've understood about the overall costing with the Hadoop, let's look at how we're going to do the same thing for the HBase and Storm. So HBase is very popular, very known for the very high throughput random reads and writes. So there are really two ways of thinking about the HBase deployment. The one way is thinking about this isolated model, where you have this dedicated projects and they have this isolated set of region servers. In that case, costing is very simple. You can just charge those specific projects for the number of region servers they use. So let me tell you about the other approach, which is a shared model. You have these region servers where all these projects lie, and they have their tables spread across all these region servers. So now it really becomes important to understand how resources would be used across these region servers. So this is how you should think about the resources when it comes to the HBase region server. There are really two parts to it. So one is the serving part, which is serving the reads and writes for specific table regions. And the other part is the storage part, which actually stores the actual data. Now, given that we have the scale, given that we have a variety of use cases at Yahoo, just the way in case of Hadoop, they go really hand in hand. And for my TCO, what I'm going to do is I divide this cost equally across both of them. So 50% for reads and write, and 50% for the storage part. You can pretty much use the model, based on your workloads. And then within reads and writes, because again, we are serving all different kinds of use cases, I'm going to give 25% to the reads and 25% for the writes. And I think you can pretty much choose a model which fits your specific workload. And that's the one large assumption. The second assumption is, and it's quite true, is that total reads and write of individual region sums up to the total reads and writes of the overall region server. So with these two things in mind, there are really going to be 4 things I'm going to track. So first thing is the write. Across all my region servers, I'm going to look at how many writes I did. And then with my TCO, the cost that I want to drive is the dollar amount for 1,000 writes. You can take other unit as well, but I took 1,000 because we have millions and billions of writes happening over a month's time. Similar way for the read, I'm going to look at the total read operations done across the set of region servers in a month, then take this read TCO, which was 25%, and then divide the total reads with the TCO. Third is storage. Storage is quite similar, just the way we did in Hadoop. There is an actual amount of data you can serve through a specific region server. And what I'm going to do is I'm going to take the 50% of the TCO and divide that with the total possible raw storage that can be served through region servers, and then come with the dollar amount for the GB stored. Bandwidth is quite standard, the amount of GB which can come in and go out, and then dollar amount for that. So reads, writes, storage, and bandwidth. So let me walk you through a quick example here. This is quite fictitious, illustrative. Assume that I have this 1,500 nodes where the monthly TCO is roughly $60,000. For the writes part, I said 25%, so that is around $15,000. And over a month's time, I found that total number of writes done were 100 million, which will give me a unit cost of 15 cents per 1,000 writes. Similar way for the reads, I'm going to look at the total number of reads done on a monthly basis across region servers. In this case, it comes around 200 million, so the cost becomes 7.5 cents for every 1,000 reads. Storage is quite simple. I found that across my region servers, the total data I can serve is 10 petabytes. Now, I keep in mind the replication factor, and that will give me the actual raw storage of roughly 2.67 petabytes. So therefore, my unit cost comes around 1 cent for 1 GB of the data served through the region servers. And network bandwidth remains quite the same. So now that you've got your unit cost, what you're going to do now is do this measurement for individual projects. So you take a project, find out all the regions of that tables of that specific project, and then calculate the total number of write operation that was done across the regions. It's very simple to track. There are really 2 ways of doing it. You can actually pretty much go to the H master page, or you can even pass the JSON file, which is in /master JMX, on a continuous basis to know the aggregate over a month. So once you know that part, and you know the total number of writes done, multiply that with the unit cost, and that'll give you the overall cost of serving the writes for that specific project. Similar way for the reads, know the total number of reads done across the regions of table, multiply that with the unit cost. It's all post facto, by the way, and then arrive to a number for the reads. Storage is quite simple. If you go to your name node and go to HBase/table, you'll see all the regions there, and you can look at the overall storage, that is the data size, which is served by the HBase. Just sum it up for the specific tables in a project, multiply that with unit cost, and you'll find out the cost for the storage. Bandwidth quite similar, divide this proportionally across all the applications. So now that you have done it, roll it up across all the BUs and the project and the respective tables. This is how a final build for the BU would look like. So now let's move to the Storm part. Storm is really a very good technology when it comes to real-time processing, and you might be aware of the deployment here. Again, there are 2 ways of thinking about it. There is one which is isolated mode, where the topologies of a project really get a dedicated set of supervisors, in which case, again, costing is simple because you're going to cost for the individual supervisors used by that topology. The other model is a shared model, again, where the workers for the various topologies across projects will share the same set of supervisors. So how do we think about resources in that case? If you look at any supervisor, logically, we have divided that today into the partitions, which are called as the worker slots. It is really logical right now. We say if I have this 96 gig of machine, every slot is roughly going to be 4 gig, so we have 24 slots for the worker per machine. And that's the idea here. And what will really happen is whenever you launch any topology, they would be occupying one of these, some of these slots. So that's like in terms of the slot usage. Second thing there is a time notion. Typically, topologies are long-running jobs, but that's why you should really look at like for how long the workers occupied the slots of a specific project, of specific supervisors. So when you have these two notions in your mind, you're going to really track, first thing is compute, right? So you're going to look at in terms of slots and hours. So I roughly know the total size of supervisors that I have. Then I also know the total number of slots that I have per supervisor. And assuming that I'm going to run this whole cluster for 24/7, so I say 24 hours and 30 days, I'm going to come to a notion and derive a notion of slots hours. And then I'm going to attribute a dollar value to it by dividing the entire TCO of my cluster with the total slot hours. Bandwidth will remain quite same. So here's an example for that. Let's say, assume I have 800 nodes of supervisors here, and over a monthly cost was $30,000. I convert this to these slots first. So per machine, it was 24 slots. It becomes 19.2 thousand slots. Convert that into time now. So multiply that with 24 and 30 days and 24 hours in a day. It comes around 13.8 million slot hours. Take the entire cost, TCO, and divide with this number. It'll give you the total dollar amount for the slot hour in a month, which is 0.2 cents roughly. Bandwidth remains the same. You're going to divide it proportionately. So same thing, you're going to track. It's very simple to track. If you go today to the Storm UI, or even if you query the Nimbus over the REST APIs, you'll find out the number of workers spawned by a topology for a project. And then you can find out also for how long those slots were used, because that's for how long topology ran. I'll come to that quick. And then multiply that with the unit cost will give you the overall size of the project. So that was really about measuring the overall cost for a project topology. Do this across BUs, find out all the projects topologies, and do this for the slots across that. So now you did costing. There's another notion here. There will be projects who are using HBase and Storm and Hadoop together. You're going to just fit in all the things together and give them this consolidated bill. We don't really do this religiously today, but we're going to follow a similar kind of notion. But don't stop here. You did all these costing exercises. Why not look at it from the profit and loss statement? You are a company. You're making some a revenue out of it. And your platform is definitely a cost component to this one. So what is the contribution margin of this? And is it really justified? If you do this kind of analysis, because you now know your operation expenditure, now you know your overall CapEx, you know what contribution margin is your overall platform cost to the revenue, and is it really justified or not? And then if it's not justified, what exactly can you do? There are really two things you can do. You can benchmark your cost against a public cloud, or you can look at utilization. So let me just talk about both of them. Benchmarking is, again, a quite tedious task. There are really two ways of doing it. One way would be you'll try to simulate your actual workload on the public cloud. And I think that's a very difficult route. I tried doing it. It wasn't possible. So I took more of a logical approach, a hypothetical approach, saying this way that the public cloud really works in a way that you have an instance and you have it for certain hours. And then you're going to pay money for that specific instance hours. So how many instances do I really require? Let's say in case of Hadoop, if I have a need of certain map reduce slots and SDFS or instance storage, how many instances do I really require for how long time in the public? And it's really about extrapolating this used part of it to the public. So let's say I have a map reduce slots. I say, okay, I require these many numbers of instances on the public cloud for this much of time, and that will give. And then I can literally multiply that with the cost, which is pretty much published, or you can even use the AWS calculator for that, or any other public cloud. In case of storage, which is SDFS, I may not keep my data directly on the HDFS on instance. I will keep it on S3. And keeping in mind the replication factor, I'll multiply that again with the unit cost. But when it comes to really processing a data, I'm going to push my data to the instance for the local processing. So I have to also find out how much of the instance storage I really require, and then multiply that with the unit cost. That will give you a broad benchmark in terms of your overall needs in the on-premise versus the public. HBase is slightly tricky because it's driven more by the throughput requirements. So you have to, like I personally did some of the benchmarks and said, okay, if I have a requirement for a specific kind of throughput, how many instances in a public I require to serve that kind of throughput requirements? And with HBase, the notion is it's kind of persistent storage. So I'm going to keep it for an entire month overall. So one of the driving factor really became there was a throughput and the benchmarks based on it. The other way to again look at is the memory requirement because the HBase is really a memory hog. So you're going to look at how much memory you can really serve through one specific instance on public and then find out number of instances based on that. Storage doesn't really dominate it too much. So once I know that part, like number of instances required on the public, I can again do a cost benchmark because I know the unit cost of an instance in public. Storm is quite similar to Hadoop. I know total number of slots, hours required for my projects or the applications overall. I know how many instances I will really require to spin off to have that kind of slot hour and then do it for the time it requires. So like that's the whole idea of the benchmarks. Again, fictitious, like the numbers, whichever I've shown here is not real, but this is an approach for you. So what do you really gain insight in terms of benchmark? You got to know your price competitiveness. So that's one thing you can come out of it. But you can do another thing here actually, which is the focus on the utilization. And that's a very important aspect. What happens is both of these, public and on-premise, the cost curve really behave very differently. The on-premise has a very high startup cost. But as you hit a right set of utilization, and as the scale really comes in, you'll find out that the costs tend to normalize for the amount of requirement that you have for the project. And you'll figure out that the cost that you're paying on the public gets actually more expensive because you have a scale on on-premise and you also have a better utilization. And that's another way of looking at it, that at the end of the day, you did all this cost exercises, you did all the exercise of the utilization. The idea there was to really look at the ROI. At any point of time for any application, if you look at, or any project that you're running, the ROI is the total revenue by the respective app, the cost of the app, and that difference is profit. But as you hit scale, the cost of the overall platform get divided across these projects. So your unit cost for project goes down. So you will see for the same set of revenue, you are actually hitting a better profits. So that's the concept of the ROI, and that's the whole idea of really doing this whole exercise of costing. So that's overall about the cost models. These cost models are what we have as of today, but as the new work gets done at Yahoo across all these technologies and come to life, we'll have to change our cost model overall. So far, we have been tracking only memory and cost based on that. But as more and more resources get added, like in case of Hadoop now, CPU gets added, or let's say network awareness gets added, you'll have to include those resources in your cost model going forward. The other notion is Thais. Thais is a totally different framework. There's a whole notion of reusing containers. That will also come in the picture. Preemption becomes very tricky now because a low priority job will be killed, but still it uses certain amount of resources. So you also have to account for those kind of things when it comes to the Hadoop cost model. HBase, something exciting would be to look at the multiple region servers per node. So far there was only one region server. Now you have multiple region servers, so you have to think about dividing cost across those region servers. So that's one of those. Second would be thinking about resource-aware HBase, which is over Yarn or with the C group profiles. You have to again take into account those specific resources like CPU along with the memory. And same thing pretty much goes with the Storm. That as you get into the area of the resource-aware scheduling, you have to look at the overall CPU usage and memory usage by the slots, and then divide the cost accordingly. So that's like some of the work that we're doing, and we'll be evolving our cost models accordingly. And that's the overall end of our presentation. I'll now invite you for the questions.
Question.
My first question is, can we get these slides?
Sure.
We can upload it, yeah, it's not a problem. Yeah.
And my second question is, what's the best way of going about getting these numbers
Yeah.
And archiving them?
Totally, I can explain that. So when you think about collecting the numbers for computing TCO, depending on how your infrastructure runs and what different parties are involved in it, it might be the worst type of exercise in this entire process, collecting the data itself. So in our case, it took about a month. I had to go to data center people, I had to go to a group called network operations, I had to go to a group called capital planning group. So all of those groups have different pieces of data, but any data center operation keeps track of these costs really, really tightly. Energy, power, cooling, I mean, you name it. But the best way to go about this would be to say, I have 2 or 3 different types of hardware configurations in my infrastructure, be it Hadoop, HBase, or Storm. So you take that hardware configuration, and then just for that server, start adding those TCO elements. So let's say you purchase those servers for $5,000 post-tax, right? And you can keep that server for about 3 years. So you divide it by 36, that's your monthly server cost. And then you add how much power it's going to consume every month, how much cooling does it need every month, and a lot of those specifications come with the server itself. And then the bandwidth operations, and the network itself, the overall network for 3 years, and then you can start dividing it over per server. So that is one of the easiest way to go. Take a server, let's say you purchased it for $5,000, but when you added all the different cost components, it actually looks like $10,000. And then your overall cluster has 100 of those servers. You just multiply that by 100. That's your monthly TCO for the total infrastructure or your entire operations. And then you can go about doing everything that we were showing.
Sure.
So
Yeah.
curious to know, you had mentioned several components on Hadoop ecosystem. Do you guys had all of those components running on a one infrastructure, or you had a separate infrastructure for each one of them?
Yeah. So we have multiple data. Oh, sorry, I'm sorry. So the question was, is it all a single infrastructure or is it multiple infrastructure that you have consolidated in these cost elements? So we have an infrastructure that spans multiple data centers, and within the same data center, there are multiple clusters. The clusters are then designated in multiple categories. There's a category of cluster called production cluster. There's a category of cluster called research cluster. There's a category of clusters called sandbox cluster. And the idea is to take applications through this, or software deployments through this phased process of sandbox research and production. The production footprint is the largest footprint. The research and sandboxes are much smaller. But when you think about all the clusters we have just for Hadoop, there are about 16. And that's just these production research and sandbox. And there are development clusters, performance clusters. We've not included those here.
But within the same environment, let's take an example of production, right? Do you share that environment for all the, Edge-based, Storm, and Hadoop?
Oh,
There are components get
Yeah.
reused, like Edge-based uses, underlying
Sure.
Hadoop as well, right?
Yeah.
right.
How do you account for
Oh,
some of those things?
they are isolated. So I think I tried to show a slide,
Yeah,
and the deployment slide. I'll see if I can go back to that. I'll be very clear. So there's a lot of build here. It'll take me a while. But it's important to understand because different people deploy things very differently, even across companies, even within the same company. Everything I'm talking about here is a central platform that we call as the grid at Yahoo. There are other types of deployments also at Yahoo. So this is the deployment that we have. As you can see, all of these infrastructure, Hadoop, HBase, and Storm, are sharing a common network backplane. So they can each talk to each other just as if a data node in one Hadoop rack is talking to, in the same cluster, is talking to another data node through top of rack switch. It's about the same. So you just go through there to an HBase or Storm. So your network architecture highly influences how you're going to go about deploying these technologies. Never ignore that. And the idea there is the flatter your network is, the easier it is for you, or you have more flexibility to do different things. But these are isolated deployments, 3 of them. But it's possible only because of how our network is.
So another question I had is, so at some point you may have a non-Hadoop platform and you may have migrated to Hadoop, right? Did you compare the TCO between two?
That was way, way before my time. That was like 2003, 4.
So how does it compare? Because that's where
It's Hadoop is very cheap. Let me put it this way.
the hardware and software, but
Yeah.
the manpower and the skill set, Hadoop skill set is rarely,
So we have a lot of history. We've been doing it 10 years. But the other way to go about not acquiring those skill set very quickly is to use a commercial distribution, like HDP or CDH or whatever. Then you don't have to, mingle with the nitty-gritties of what we do. That's one way to circumvent headcount. And those types of headcount are very hard to find.
even
Well, that's why we do Hadoop Summit. We're trying to share all the learning. Go ahead.
Some of the metrics that you use, I infer that you could have some unused.
Yes,
Yes.
yes,
So
always.
how do you roll that up in the analysis? Because would you have like unused capacity utilization?
Yes.
It will still be part of your total cost. So when you're costing yourself, when you're charging somebody, you're only charging for the used portion. But when you're looking at your cost, you will still incur that cost. Whether,
Yeah.
let's say I'm incurring $2 million and no one's using my platform, I'm still incurring $2 million.
As you roll it up corporation, who do you charge it to? Just
Say that again. Who do you charge it to? We don't charge it to anybody. This is an approach. Our P&Ls are very centralized. So this is something called as a showback. We don't really charge anyone or bill anyone. But if you were to bill one, let's say I were to offer my services to public or in a retail model, what would that bill look like at a cost basis? And then I'll put markup on top, and that'll be my price.
so you don't have like internal pricing.
No, we don't do that. We don't charge each other. We do a showback.
And I think that's where this whole idea of utilization really becomes important, because
Did
if
it?
you don't really utilize it well, then a lot of things goes unused.
Mark, it's a great presentation. It's the first time I saw some.
Business-related Hadoop topic.
Good graphics.
I think particularly for niche base, which is actually I consider as a data DDM, it's a database management system.
Sure.
Then you would be talking about the DR component
Yeah,
as opposed to a simple SDA based.
yeah, yeah,
Sure.
yeah.
It's very different. So if I take that, if I include that, it would be 2x the cost of for OLTP kind of.
Totally. So the question is DR type considerations, and the costs all get accounted for because you're taking every HBase table, and if you have somebody writing into two HBase clusters for DR type use cases, you're costing both and bringing that back to that person.
Yeah.
One other question. So you've done a lot of background work on this. Are you planning to put that as a product or collectors?
No, so these cost numbers are very proprietary to a company.
Not
Then?
the cost,
You're talking about tool as
the
such.
infrastructure to get all this information.
Oh yeah, we have a product called Starling. It's not open sourced, but it's very simple. It's just a Uzi job that is collecting log information from various clusters into a central HCatalog Hive warehouse, and then it keeps that data, cleansed data for a year, about 18 months, so you can do a lot of historical analysis. It's not hard. You can build something like that yourself. We're also thinking about open sourcing Starling at some point in time.
Sure.
Last question.
So you showed a TCO between on-premises and
Public.
Cloud, yeah.
what's usually the cost difference?
Very hard. It's impossible to say. So the question is public cloud more competitive than private cloud? It just cannot be answered without going through all your situation. One thing, and that's why we showed the utilization slide, where there are two factors that come into picture. The utilization, how heavily utilized your own infrastructure is, and how much scale do you have. There is a crossover point, as we have seen in our sensitivity analysis. So if you just look at your own utilization and your sunk cost and your infrastructure, you might look less competitive than a public cloud. But as you start to do the sensitivity analysis as to, okay, if I get few more projects, then what? If I add few more nodes, then what, right? So you have to look at what that crossover point is for your use case, for your workloads, for your data, for your scale, for your utilizations. It's impossible to answer. But in general, if you have very few nodes, you might find that it's okay to go with a public cloud to get started. And then as you start to get your monthly bills, you will start to think about doing this calculation and see, okay, should I go this way or should I go that way? But for us, the scale we have, it's a no-brainer on-premise rules. We did that exercise.
All right.
Thank you so much.